How's it going? This is my video recording. So for Q1, we have given the transformation of r square goes to r square with TAB is equal to 1, 1, 1, 1, AB. We need to state at least four vectors that are in the root of 1. Pen works? Yeah. So transformation is 1, 1, 1, 1, AB, right? And that will give us A plus B, A plus B, right? So we know this means that A is equal to negative B, or you can say B negative A. So because of this, we have our four vectors. So in the range, you can have any real number for A, because our range is A plus B, and well, for all A's are real numbers, right? So our four vectors are for V1, we just have 1, 1. For V2, we have 2, 2. V3, we have 3, 3. For V4, we have 4, 4, right? And this can be whatever. We can have like 1, 7, 3, 4. Doesn't really matter. As for the null space, though, the null space we have to have for A and B here. It has to be A equals negative B, where A and B are all real numbers, right? So this means is that when we put our two vectors, so in other words, one of them is 0, 0, because that will always give us the identity. So then for the other one, for the second vector, I put 1, negative 1. So if we do 1, negative 1, we'll get really just 1 minus 1. That gives us still the identity. So that works out. Same for 2, 2 minus 2 identity. 3 minus 3 is identity. So those are our four vectors, right? So and that's why I have my conclusion here, where we have matrix 1, 1, 1, 1 times matrix AB gives A plus B, A plus B, and A and B can be any real number in the range of P. Null space, it's only possible when A is equal to minus B. That is for question. Question get. We have given T the transformation from P1 to P1, and we know MT 1, 1, 1. Therefore, oh, and of course we have our alpha, 1, 1 minus x. Our beta is x, x minus 1. We have to describe the range, space. So for this one, know that the transformation is form a px, and it goes to 8. And we know we have a matrix 1, 1 for MT. So transformation of 1 is ax plus times x minus 1, right? And this was the same thing here. Place the a and b with 1, 1 because that's what matrix MT, and get 1x plus 1x minus 1 with x. And then for transformation of 1 minus x, it's the same thing. Have 1x plus 1 times x minus 1, and that's still minus x. So because of that, we know for all the v's, we have a plus x form 1. So we can say v to a1 plus times 1 minus x. And this gives us the transformation of v equal to transformation of a1 plus 1 minus x. So here's our work, right? Just change this to a1. We take out the a and the b, and we know the transformation of 1, know the transformation minus x. So we replace t1 and x, which gives us a x minus 1 plus x minus 1. So we can factor out the ab, so we get a plus b times 2x minus 1 for all a's and b's, right? So we can say our range for is a plus b times 2x minus 1, where a and b are all real numbers. And as for the null space, because of this part right here, the a plus, well, when we transform it, it's going to give us this form. So a has to equal minus b or minus a. And so when we do this, I just put our range is just 1, 1, 2, 4, 4, which works for all of them. As for the null space, we have these right here. So if you quick, it's 1 minus 1, right? Because that's what it gives us, times x, x minus 1, x minus 1. This will always be 0. 0 times any 0, which is identity. So this will work for all of them. So in conclusion, since t1 and t1 minus x are both 1, we know v is in the form of basically a plus bx. And since we know that t1 and 1 minus x is x minus 1, get this here, which is the a times um, x minus 1 and 1, this, and thus our range. And for the last ones, we have, given the m already, we have the transformation of alpha and beta. So we have matrix 1, negative 1, negative 1, 1, 0, 0. So we know, well, these are our givens right here. These are our givens. We know alpha is 1 and u2, and b equal to v1, v2, 3 for all the vector spaces. U, v over the field. So we need to evaluate tw, where w is right here. W is equal to AU1 plus AU2 for all alphas. And of course, we need to state vectors, right? But since we know TW is AU1 plus AU2, we can say that TW is this, because this comes from over here, times AB, right? Because these are our scalars. So that gives us A minus B minus, well, we gives us the matrix A minus B, negative A plus B, 0, 0, of course. And this is for TW uh, for the range. So our four vectors that we can are 1, 2, 2, 1, 3, 4, 4, 3. All these are real numbers, so they work because they won't give us the identity. As for the null space, as long as A, B, it will always give us the identity. Try out for the first one. We have 1 minus 1 minus 1 minus 1, 0. This still gives us 0, 0, 0, which is still the identity. And same for if we do it for 2, we'll have 2 minus 2 plus 2 plus, right? You still get 0, 0, 0, which is as the identity. That works, right? So in conclusion, since we know what MT alpha beta is, which is here, matrix 1 minus 1, negative 1, 1, and 0, 0, we can assume that W is AU1 plus AU2, and this will give us this. So when we transform W, and therefore we get this right here, the A minus B, negative A plus B. Okay, so when you have A equals B, get all the null spaces, because it will always like cancel out. It would always give us the identity here. And for our range, we have matrix A minus A plus B, 0, where A and B are all real numbers, and our null spaces is comes from the um well this part. Excuse me. And we know that one is 1 minus 1, negative 1, 1, 0 times AB, right? So we have that. We have the original matrix from NT times AB, and that would be A equals B, where A and B are all real numbers, so they have to be the same in order to give us identity. And that concludes my video recording number 2 for questions 1, 2, and